All right, so we're going to be talking about inheritance. So what we're going to do is I'm just going to go ahead and make another console application, or whatever you have to choose to make your console application on screen. I know it's slightly different because mine's not capable of making Mac applications or anything like that. So anyways, okay, so the way inheritance works, and I think we talked more about interfaces last time than inheritance, is you have what's known as a superclass or a parent class, and then you have a subclass or a child class. And I don't recall particularly which one our text refers to it. So you can also call the superclass and the parent class as base classes. That tends to be the C++ term of choice, and so we're going to use it here. So the idea behind inheritance is that you have a base class, and then you have an inherited class which adds stuff to the base class. And then that one can inherit it. It can use the inherited class as its base class. Jason, Jacob have to leave? All right. Okay. So we could come up with an idea like, I hope I didn't give the same example last time, a shape class. And the shape class could, have very minimal information. Like maybe it could have an X, Y, and coordinate to where it is, out in outer space or, on a map or something like that. But it doesn't have anything else. And then we could make a base class, and the base class would inherit everything from the shape class and then have some additional stuff. And then we could inherit from that class to add some special capabilities to the next one. So what I'm thinking is we make a shape class, and inherited from that could be, there are circles, there are also triangles, and then there are rectangles. We could have 3 subclasses of the shape class. And then if we wanted to, we could have a square, which is a very specific form of rectangle with the sides set to the same thing. Now, if we were really awesome, we would use abstract methods to enforce that every single one of these has a get area method. An abstract method is one with no body. And anything that inherits from it has to implement that. So you use the abstract keyword in order to denote an abstract method. And once you've added an abstract method to it, then you have to make it an abstract class, because you can't create an object that has an abstract method in it, because then what if the calling code needed to call it? What should it do? Blow up? Crash? No. It just forbids that. If any class has an abstract method, then it needs to be declared as abstract as well. So an abstract class, and we wouldn't have to make an abstract class in order to get this to work. The reason we could just use overriding. Maybe we'll do that instead. Make it a little bit simpler. But an abstract class is a class with an abstract method. An abstract method, which you need to know in order to understand what an abstract class is a method with no body and must be created, must be coded for any class, any non-abstract class, that uses the abstract class as a base class. So our shape class, it's not going to have anything except for a get area method. And all get area is going to do is, well, I said that I was going to add, x, y coordinates. I guess we could do that as well. So get area method So class shape, we're going to have an x and a y coordinate. It's a property. Since it's a property, I'm supposed to, by all standards, capitalize that. I'm not putting a field behind it because I'm not going to do any validation on it. So I don't need to actually encode a getter and a setter. You know, we're just going to allow them to set it to whatever number they want. If we wanted to set some boundaries for it, you know, they could not set, you know, x equal to, you know, something less than 1, then we would actually want to put some code in to a setter, in which case we'd want to make a field called lowercase x, and the getter would return this dot x and the setter would set this dot x. But this is an auto-implemented property. Okay. I'm going to make it public because everything by default is private in a class unless you use a public keyword. These things support structs. Yeah, they do. The difference between a struct and a class is conceptually structs are used only for data. They don't have methods. That's the concept. However, in reality, you can go ahead and add methods to it. The only difference is that by default, the members of a struct default to public rather than private. And in a class, the default access is private. You don't use structs because actually, right, that is the same thing with a different default. If you look through C code, though, you'll see structs because C, the original programming language that all these other ones, you know, were based on, do not support classes. They just support structs. And so you'll see people who trained in C continue to use structs and these other things, but you would only use structs for things that contain data only. And nowadays we would even use classes for that just because that's how we think. You might want to add methods to it later. Okay, so we have an X, we have a Y, with a getter and a setter. Because everything out in the real world could have, you know, an X position and a Y position. We could make a constructor that sets those guys. So that if we wanted to create a shape, it would be easy. And a constructor is a method that has the same name as the class with no return type, and it can set the variables. So public shape, it takes an X coordinate, it takes a Y coordinate, and it sets X equal to X and Y equals to Y. So that's our shape class. Anything that uses this as a base class is going to pick up that constructor. Now we might want to add our own constructor, you know, like for a square that lets them specify a side, right? How many sides, or excuse me, you know, the length of the side. But it would then need to invoke the shapes constructor as well so that they could also specify the X coordinate and the Y coordinate if they so chose. Maybe we make two versions of the constructor. Since we have a constructor here, a parameterized constructor, that means that there's no default constructor anymore. I cannot go down to main. I'm not going to do it here, but I could not do this. Shape X equals, don't type this because I can't. I can no longer do that because I have a parameterized constructor, meaning I have to call it with arguments to fill in those parameters, unless I provide default values for them. That's plausible. Do I like that idea? Nah, I don't think so. I think I'm just going to make a default constructor, which is one with no parameters. Public shape, parentheses in it. Don't do a dang thing. No, don't put the semicolon there. My mistake. Now this line of code would work if it was in the right place. Right? It's not. I'm not going to go down into main and type it just to prove that it works now. Just accept it. And this is a default constructor. This is a parameterized constructor. And these are auto properties, meaning that you don't actually have to, since it's auto, you don't have to put a field behind it. You don't have to make a lowercase x, right? Does all the coding for you. I like that. I kind of wish Java had that. You know, the two languages steal stuff from each other all the time, and I wish Java would steal that. Since C# started off as Microsoft's copy of Java when after a lawsuit, then Java felt free to borrow syntax back from them. All right, so that's our class. I'm going to compile it, make sure I haven't made any mistakes. I'm getting, oh, I have not put a close comment here. So if you did bother to type all that, which I don't particularly recommend you do, then you better close your comment. All right, but I do want to compile it. Scare out any syntax errors. Oh, and by the way, I know that none of y'all have done this, hopefully. But if you ever get that error message that says you have a syntax error, do you want to run it anyways? Okay, good. It's not even doing that. But in the C++ compiler, it will offer to, run it anyways. Never run it anyways. And absolutely never run it anyways and click the little checkbox that says don't show me this dialog again. Because that means that every time it runs, if it finds an error, it doesn't matter. It'll run the prior version. And you'll wonder why in the world your last changes aren't in there. And so that's happened in one of my classes, and I don't know how to reset that setting. So they keep saying it's not working or these changes aren't working, and I go over there and it's because there's errors in the program and they haven't checked their error list, and they don't know that it's not working because they're not getting the pop-up dialog. All right, anybody need time to finish typing this part in? We all good? All right, so let's make a circle that is a shape. We don't use the extends keyword like you do in Java. Instead, you use a colon like you do in C++. So class circle is a shape. It inherits from shape. Shape is the base class. Now I'm going to compile that. All right, good. Still no syntax errors. Now circle has everything that a shape does, but it's got something else. It's got a radius. So let's just make that an auto property as well. If we ever need to make it more complex with data validation, then we can make it a field and the property would have a coded getter and setter. So public double radius curly brace get semicolon set semicolon. And by the way, although we haven't gotten to it, the reason why you provide properties is so that if you're in a .NET environment with a server that supports .NET, then you can tie controls on a web page with these properties so that if somebody types something in, then it gets set directly into that property. The web page, the web server knows that once you've created this web page, then that field is tied to this property. And it can't do that if it's just a field, if it's just a variable. It has to have the getter and the setter. Alrighty. Now I want to provide a getArea method, but I want everything that's a shape to have a getArea method, even if it doesn't do anything. So in that case, I'm going to go back up to my shape class and add a getArea method. And technically, this should be an abstract method, but I'm going to avoid using the abstract keyword. We'll go back and fix that in a minute. We'll make it, well, towards the end of the lecture. So public double get, and this is inside the shape class. And the only reason we're adding it is so that the compiler knows that everything that inherits from shape has a getArea method. Why did I write getShape there? getArea. In this case, it can't calculate anything, right? So I'm just going to make it return a 0. It's a useless method, right? That's why I should actually make it abstract. And then the circle class needs to override that to do something useful. And I would like the circle class to have a constructor. so that they can specify the position of the circle if they so chose. Now let me make sure I get the syntax for this exactly right. Calling base class constructor. I'm Googling, by the way. I guess I could be doing this right, in front of everybody. Calling base class constructor in C#. Learn how to call base class constructors in C#. Sounds good? No. Okay, all right. So here we have an account class. We have a party account class. Here's a constructor that we want to call from the subclass, from the child class. And so what it does is the syntax is just colon base parentheses in parentheses. In Java, it's the super keyword instead. Java likes to call them super classes. C# calls them base classes, so I guess it makes sense that in Java this function name would be super, and in this one it's base. So we're going to add two constructors to the circle class. One that requires them to pass in the x and a y coordinates, and one that's just a default constructor. But not only the x and the y coordinates, we're going to also let them specify the radius as well in that constructor. I could see us coming up with a whole bunch of different constructors, and I only want two of them. I just want to show that we can make one constructor that invokes that one and another constructor that invokes that one. So this one accepts an x and a y and a radius coordinate. It doesn't have a return type because that's the definition of a constructor, a method with no return type. This is the default one. All it needs to do is return, or not even return, call the base class's constructor, and it's all done at that point. And why did I make it radius? That's not the name of the class. The name of the class is circle. And why do you not like that? Use of keyword base is not valid in this context. Says who? Let me pause and figure that out. All right, sorry, my brain slipped into Java instead. Instead, you put the constructor call before the curly brace, after the closing parentheses of the parameter list. You need to do that. And if we so chose, I like to move my curly braces up on the same line when it's just a default constructor. Now I want to make a constructor that sets the x and the y and the radius values. So we're going to add another constructor, parameters, x, y, and radius, public, circle, and inside there, double x, comma, double y, comma, double radius. And this one's going to call the base class, but it needs to call the special parameterized constructor. It needs to pass in two values. So we're going to do base, parentheses, x, comma, y. Call our base class and pass in these two parameters. And oh, by the way, we need to set our radius equal to the radius that was passed in. Forgive me for typing something and seeing as this works. Don't type this. No. All right. Now I haven't added a getArea method yet to override the one in the root class, base class. But I'm in a hurry to go down to main and actually try to create one of these to make sure that I haven't, egregiously messed up the syntax. So I'm going to go down to the main. And by the way, I should have put these inside the namespace. I didn't. Actually, they should have been in their own file. But I'm going to come down here, find main. I'll scroll back up if we need more time to type that in. I want to create a circle both ways. Circle C1 equals new circle, calling the default constructor. And then circle C2 is equal to new circle. And it's at coordinate 10, 10, or 10,20 because I happen to type that, with a radius of 100. That's the custom constructor, the parameterized constructor. I don't see any red marks. It looks like I may actually have managed to type that in without too many syntax errors. Let's find out. Did it build? Woohoo! All right. Now I can create a shape because it's not an abstract class. When I make it an abstract class, this line is going to fail. Shape sh1 equals new shape. Right, so I'm not going to illustrate much about that. I'm not going to call the parameterized constructor because I know pretty soon that's not going to work at all when I go and start adding the abstract keyword here and there. So our other classes have been above namespace, and if we were awesome, we would have put them in their own files. At the very least, we could have defined them inside the namespace rather than outside. Doesn't really matter though. The namespace is just to make it easy for other projects to be able to locate them, because you could have multiple namespaces inside the same, inside the same project. All right. Scrolling back up to our circle class, we want to add the getArea method. Why don't I just copy that one, paste it, and make a change to it? Copy getArea out of the shape. Oh, by the way, I love making these little comments. This is the end of the shape class. This is the end of the circle class. And I'm going to paste my getArea method at the bottom of the circle class. Well, not underneath it, just inside the comment. The closing curly brace. And it doesn't return 0. That's not how you calculate the area of a circle. It's just pi r squared. So return math.pi, oops, lowercase I, times radius squared. Why are you complaining? Was it an uppercase I? Oh, it is uppercase I. All right, there we go. So this is an override. We could add some comment to the effect that this is an override, / overrides getArea from the base class. But nah, I'm not going to do that. Why did I add this up here to begin with? Because I want to allow polymorphism. And what polymorphism is when multiple objects can use the same method call with multiple results. And so I'm telling it that every shape, regardless of what kind of shape it is, a circle or square or whatever, is going to have a getArea method. So I can just store references to shapes rather than require different methods that require a circle or a square or whatever. Maybe that'll make sense when we actually demonstrate the polymorphism. Okay. So we could make a shape. Why don't we just make a square? We don't have to demonstrate inheriting from an inheriting, in my opinion. I don't know, it might be fun to do that, but that would require creating a rectangle class and a shape class. I don't feel like making this overly complicated, so we're just going to make like a... Yeah, let's do the rectangle class, and then later on, if we feel like it, we can derive a square from rectangle. Okay. Honestly, the fastest way to do this would just be to copy and paste this, change all the references from circle to rectangle, change these variables. No, that's beginning to sound like too many changes, so we're going to create one fresh. class rectangle, R-E-C-T, is also a shape. This is the end of the rect class. And a rectangle has two parameters, two properties. It has a height and a width. So, double height. I wonder if you can define them on one line. Nah, that's a little bit overzealous. Get, semicolon, set, semicolon. Do the same thing for width. Get, semicolon, set, semicolon. And while we're thinking about get area methods, why don't we just go ahead and copy and paste that one and change the formula. So I'm going to copy get area. Then I'll go back and add the constructors for it. So the area of a rectangle is just height times width. Now for the two constructors. The default constructor, all it does is call the shapes default constructor. And then the parameterized constructor that calls the constructor and allows us to set the x and the y coordinates. I forgot to add the word public here. Technically speaking, we wouldn't have to make height and width public, but it seems like I've been making all the properties public up to this point, so why not? Public double height. Public double width. Public RECT colon, and we're going to call the base constructor with no values. Now we didn't have to do that. We could actually pass in, and call the parameterized constructor like that. That would work. Just as well, you can call whichever constructor you want. Not going to bother. Oh, what have I done wrong here? Anybody spot the error? What is rect? It's a method, so what syntax have I left off?
Yeah.
These guys. Yep. And that's enough. I don't need anything else. It's just a default constructor. It's not doing anything special. And then this one's going to look a lot like the circle constructor, except it's going to have two variables. It's actually going to have a total of 4. It's going to have the x and the y coordinates and the height and the width. So public rect double x comma double y comma double h for height and double w for width. Just so I don't have to type out the whole words. I'm lazy. Okay. So we need to call the constructor, the base constructor, and pass in x and y. So after the parentheses, colon, base, x comma y. And by the way, this syntax is exactly the same as C++, except I think that's fair to say. So this is good prompting for that if you have to start doing C++ programming as well. There are considerable differences between the languages, one of which is that C++, at least the older versions of it, do not have garbage collection at all. Newer versions have something called smart pointers, which will support garbage collection. But what is garbage collection? It means that we don't have to worry about deleting our items when we're done with them. That happens automatically. C++ it does not. Okay. So we've called the constructor to use the x and the y, but we need to use h and w. So we're going to say height equals h and width equals w. And normally I like using the this keyword, and I would be prefixing all this stuff with this, but I haven't been in this particular project for some reason, not sure why, so I'm going to leave them off. No, maybe I'll add them this time, just as a reminder that this keyword is there. Excuse me, I should be calling it a reference. It's not a keyword. It's a reference to the current object.
What's the point of X and Y for a rectangle if you're going to use H and W?
Well, the X and the Y I was thinking of as positions on a grid.
Oh, okay.
Not, yeah, the question is why do we bother having X and Y? Aren't they synonyms for H and W? No, I've been thinking of X and Y as positions like on a grid or on a screen or something like that, coordinates.
Okay.
So, not that we're drawing them on the screen, but just so really the only reason why is I wanted to show how to call the superconstructors and pass data into them.
Okay.
All right, and underneath that is our get area method. And we could scroll down to main and we could create a rect. Rect R1 equals new rect, parentheses in parentheses. Rect R2 equals new rect. It's at coordinates 1, 2 with a height of 10 and 20. Now we haven't used the get area methods yet. We haven't printed out the areas of anything. Right, but we could. Just to demonstrate that we can, even if we don't use them and print them out. Double area equals R1 dot get area, then change it to R area equals RC1 dot get area, right? Not a syntax error, we're assuming it works, right? We could print them out to make absolutely sure, or we could set a breakpoint to make sure. What did I just do there? Stop that. So to make absolutely sure that the area is non-zero, right? C1 should be well, C1 would be an area of 0, right? But why did I make that CC2? That was not my intention. Whatever. The area of CC2 should be non-zero, so why don't we just print that out? CW console area of CC2 is space end quote plus area. Let's get a read line in there. Console dot read line. Test it out. All right, so that worked. That means it's invoking the correct version of get area. It's not calling it from the superclass, which is goodness. The reason I started wondering about that is the code example I was looking at while the camera was paused had us putting the override keyword there. Now I think I know why they do that, if it's the reason that Java does it, which is to guarantee that we are overriding something. And if we change this, it is not a valid override. It should not compile. Yeah, okay. So that's what it's there for. And it is a good idea. If you know that you're overriding a method from the base class, then you really should use the override keyword, although it's optional, because it checks to make sure that this actually is an override. You know, and an overriding is just when you provide multiple methods, you know. No, that's overloading. Overriding means that you're replacing a method with a method with the identical signature, right, with the identical parameter list from the base class. Hides inherited member shape.getArea. Use the new keyword if hiding was intended. Well, it wasn't. All right, so that's not working at all. The other reason that you use the override keyword is when the method is virtual or abstract. All right. We'll have to talk about the difference between a virtual method and an abstract method. Anyways, I'm going to get rid of that keyword. They're not abstract yet, so please go away now. Please, no more errors. All right. So we have demonstrated inheritance, calling the base classes. We have not demonstrated making an abstract method in class. To do that, since shape doesn't need a get area, and the only reason we provided it is to make sure that everything underneath it did have it, even if it didn't do anything, we're going to come up here and make this abstract. Abstract double get area, which means we have to remove the body for it. It's bothering me that it didn't require removing that. Would it still build? No. All right. Since it has an abstract method, let's make this properly abstract, no body. We're going to make it an abstract class. Now I'm still getting errors. That get area hides inherited member shape get area. To make the current member override it, go add the at override keyword. So I'm going to have to go back down. In all of our other get areas, I'm going to have to add the word at override. By the way, that's interesting to me, but I'll do it. So this is an abstract. No, it's not. It's an override. And so is this one. And now it's giving me grief because I'm trying to create an abstract object. I'm trying to create an object from an abstract class. If I double click on that, right, we can no longer do that because the shape is just an abstract concept. We can't create a concrete version of an abstract concept. So I'm just going to delete that line. If you had it there, delete it. That fixes that error. And that's by design. And that is entirely intentional. Once you create an abstract class, you can't create any objects from it. And the reason I had that there is to demonstrate that error. Okay. So why would we create an abstract class? To enable polymorphism. Polymorphism is when you have two or more classes where you're treating objects of different type as though they are of the same type but with different results. So for example, we could create an array of rects and circles. Now if it's going to contain both rects and circles, it can't be of either rect or circle, right? If I did this, rect, and I want an array, which I'm just going to call AR, equals new rect, then this isn't even going to work. I mean, yeah, it would compile, but I could not then stick a circle into it. I could not do AR subscript 0 in subscript equals C1 because these types are not compatible. But I really want an array that can contain both rects and circles. Well, it's a good thing that they both inherit from the same base class. The base class is not rect, it's shape. There we go. I have an array now that can contain 4 shape references. Right now, all it contains is 4 nulls, right? There's no shapes in it. But let's assign some. Array AR0 is that. Array element 1 is CC2, not double equals, or whatever you called your second circle. Array element 2 is equal to our first rectangle, and array element 3 is equal to our second rectangle. Now we could step through that array, printing out all the radiuses, all the areas of each one. And it will invoke the correct, get area method for each one. Simplest kind of loop is a for each loop. So for each shape S in the array CW tab. This shape has area equal to end quote plus S dot get area. Parentheses in, parentheses in, parentheses, semicolon. So even though they're all considered of the same type, they're not really all of the same type. Yeah, they are all shapes, but when it runs, it's going to call the get area method appropriate to it. If it's a circle, it's going to call it the circle's version of get area. If it's a rectangle, it's going to call the rectangle's version of get area. That's polymorphism.
Your pauses before you do that.
Yeah, and I put my pause up here before that. Why don't I just cut that and paste it after this? Now I'll be happier. All right. And so it worked. The appropriate get area method is being called, whether it's a circle or a rectangle. So polymorphism is when you have objects of different type that are being treated as though they are objects of the same type, but with different results. They're all being treated as though they are shapes, but different results when you call get area, right? Because area is calculated differently for circles and rectangles. Now in this language you cannot have more than one base class. That's different than C++. It's the same as Java. And it's a good idea. The reason it's a good idea is that the inheritance hierarchy can get very confusing if you have more than one base class. If you need to do more than one base class, you could consider making one base class and then making another class that uses that base class and then making another class that uses that one, right? You could create a hierarchy chain, or you could create interfaces, which we talked about in the past. And an interface is kind of a class, but it's just a class that specifies which methods that all the subclasses, all the classes that implement that interface have to have. And you could have lots of different interfaces. I think when we gave our example, we probably had one called 2D shape and 3D shape. Does that sound right? Was that our example of interfaces and implementation? I'm not going to demonstrate interfaces this time. I know that we did that the last time we hit inheritance. All right, did that work for y'all? Was there anything else I wanted to talk about with respect to inheritance? Not coming up with one. All right, I think that's about enough. Hope that was educational. I hope the class has been educational. Of course, there's more to cover in the topic of C#. Feel free to keep reading the textbook. Feel free to grab one of those Learn C# in 10-day books and read through it. Another good thing to do would be to explore .NET programming, of which C# is a subcomponent. .NET means that it's a structure that multiple languages that adhere to the standard can be put within, and C# is just one of those. There's even a COBOL version that'll plug into .NET. COBOL is, dates back to the 50s, but they made a version of it that'll plug into .NET.